Okay, the last thing I wanted to discuss for this lesson. Now, the electromotive force and the potential difference, both of them have directions. Meaning that if you're going to connect the batteries like this, with the negative terminals and the positive terminals connected, then the resultant EMF would be E1 minus E2. Okay, it could be E2 minus E1 depending on the larger one. We for the moment say E1 minus E2. If E2 is larger, then the answer for E1 minus E2 would be negative, and it would imply that uh, the potential is the other way around. Okay, so just that one point you need to be careful. You have to consider the polarities of the cells or batteries. So yeah, that's Kirchhoff's law, and you can see it is just one page summed up. Nothing much and nothing very difficult. Now what I want you to do is, before you come during this fifth lesson, try to derive now from your IGCSE knowledge. You already know that when there are two resistors, for the time being we are going to talk about two resistors only. When there are two resistors, and if these two resistors are connected in series, then we know that the resultant resistor, that is one thing which is equivalent to the entire thing, R, the resultant resistor would be given by R1 plus R2, right, for series. Similarly, if they are parallel, R1, R2, then the resultant is related like this: 1 over R equals 1 over R1 plus 1 over R2, right? Now what I want you to do is take a couple of minutes and try to derive these equations using Kirchhoff's law. We would stick to two resistors, then we would just say that it can be expanded to 3 and more, but stick to two resistors. Hint, now this is from the Kirchhoff's second law, and this is from Kirchhoff's first law. Hint number 2, pause the video if you don't want to hear it. Both of them use V is equal to IR. Hint number 3, rather than saying any more hints, I could say you the answer. So try it in your own, and we'll continue discussion during the fifth lesson. Enough for the morning.